Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. For most of human history, we look at factors like diet, tool use, and climate change, specifically drought or ice ages, as the primary drivers of our massive cognitive leaps. But what if one of the most powerful, sudden, and terrifying geological forces of the Pliocene epoch fundamentally rewired the human brain? This is the Pliocene Tsunami Paradox. The Pliocene epoch, stretching from about 5.3 to 2.6 million years ago, was the crucial window when our hominid ancestors, like Australopithecus, began their significant evolutionary divergence. They were living primarily along the shifting margins of the African continent, often utilizing the rich resources of coastlines and estuaries near the Great Rift Valley. Now, imagine this environment not as a tranquil beach, but as a ticking time bomb. The Pliocene was characterized by highly volatile global sea levels. While the climate was generally warmer than today, fluctuating ice sheets and significant tectonic activity, especially the rapid uplifting and faulting associated with the Rift Valley, created conditions ripe for coastal catastrophe. This led to frequent, massive mega-tsunamis. These were not small waves. Sediment evidence suggests that these events could inundate coastal plains quickly and repeatedly, erasing entire settlements and fundamentally altering the landscape overnight. For hominids reliant on predictable coastal resources, this instability presented a unique, recurring, and highly lethal selective pressure. Survival required more than just the ability to run fast or fight off a predator. It required the ability to predict the unpredictable. This is where the cognitive leap begins. To survive a tsunami, an early hominid had to develop an incredibly sophisticated form of predictive modeling. If a drought forces migration, you move inland once. But a sudden, massive wave requires instantaneous recognition of subtle environmental cues that precede the disaster. The abnormal receding of the tide, changes in bird behavior, or perhaps even recognizing subtle ground tremors caused by distant seismic activity. Processing these disparate, fleeting, and non-obvious signals into a coherent, life-saving decision, a warning system, is the definition of abstract, rapid cognition. It forces the brain to calculate temporal relationships. If the water moves like this now, the danger will arrive in that amount of time. This need for complex temporal sequencing and rapid hazard prediction is a massive jump from simple cause and effect learning. Furthermore, the constant threat required enhanced spatial memory. Because the coastline was perpetually being reshaped, dunes washed away, estuaries shifting, safe high ground landmarks disappearing, survival depended on continually updating a complex internal mental map. Those individuals who could rapidly map a new territory and remember multiple escape routes under immense stress were the ones who passed on their genes. This constant topographical restructuring acted as an evolutionary gym for the hippocampus, the brain region critical for navigation and memory formation. And finally, the tsunami paradox drove social cooperation. Predicting a mega-tsunami is complex, but surviving it alone is nearly impossible. Groups that could develop effective, specialized communication systems, shouts, gestures, or early linguistic signals designed purely for warning, would have a radical survival advantage. The pressure wasn't just physical, it was social, demanding the encoding and transmission of critical knowledge across generations. The story of the rising water, the strange smell, or the shaking ground became the first critical lesson taught, securing the lineage of highly communicative, predictive thinkers. In essence, the volatile geology of the Pliocene didn't just push hominids into new habitats. It forced their brains to evolve faster, rewarding those who could perceive the invisible forces of nature. The catastrophic coastal events were not merely setbacks, They were the environmental crucible that forged the modern human mind, hardwiring our ancestors for complex foresight and abstract thinking. We carry the neurological legacy of those ancient waves in every decision we make. For more incredible facts like this, don't forget to subscribe and turn on notifications.